Hello everyone, my name is Junosuke Oda. My presentation topic is Heliocentrism of B.C. Do you know heliocentrism? Heliocentrism is 地動説 in Japanese. Conversely, 天動説 is geocentrism in English. Currently, it is common sense that planets, including the Earth, we are on, orbit around the Sun. But it's the story of the modern age when science and technology have developed. How did people imagine the universe in ancient times when there were not enough observation devices? And today I would like to introduce the appearance of the universe that a person from the BC era imagined by observation about 2000 years ago. In first place, is the Earth a sphere? Actually, the fact that the Earth is a sphere was known quite early on in ancient Greek people, because they know the lack of the lunar eclipse was round, and the time when the sun and stars rise differs depending on the longitude, and ships heading to the land from beyond the horizon can be seen in order from the top of the mast. From this, it was common sense the Earth is a sphere for ancient Greek people. You may have heard of the geocentric theory and the heliocentric theory. The geocentric theory is the idea that the center of the universe is the Earth, and the Sun, planets, and the other stars are orbiting around it. On the other hand, the heliocentric theory is that the center is not the Earth, but the Sun, and the Earth is just one of the planets that orbit around it. Now, no one does the heliocentric theory, but only about 500 years ago, it was believed that the geocentric theory was the true form of the universe. From the perspective of the Earth, other celestial bodies are small points and move in the same way as giant Earth. So it is natural to think the Earth is the center of the universe. But there was a person who advocated the heliocentric theory more than 2000 years ago. His name is Aristarchus of Samos, who was one of the ancient Greek astronomers and mathematicians. In Greece, when Ptolemy and Aristotle's geocentric theories was dominant, but he proposed the heliocentric theory by reasoning based on his own observational data. His theory is this. At the time of the half moon, if you measure the angle between the sun and the moon to the earth, you can get the distance to the sun. If you know moon radius, you can get the sun radius by using the fact that the apparent size of sun and moon are almost is the same. It looks like this in a picture. Assuming that sun is at infinity, the angle between the sun and the earth at the time of the half moon is 90 degrees. If the angle θ is obtained by observation, the ratio of the distance to the moon and the distance to the sun can be obtained using the trigonometric ratio. Also, when viewed from the Earth, the apparent size of the moon and the sun is almost the same. Then, from the similarity of the triangles, it can be seen that the ratio of the sun radius and the moon radius is same as the ratio of the distance to the moon and the distance to the sun. I will explain his theory later. Before getting into the main subject, first find the size of the moon and the distance from the Earth. Aristotle used the lunar eclipse to find the radius of the moon. The distance to the moon moves from beginning of the partial eclipse to the total eclipse is equal to the diameter of the moon. And the distance the moon moved from the beginning to the end of total eclipse is equal to the diameter of the Earth. And it takes 15 minutes from the beginning of the partial eclipse to the total eclipse. The time from the beginning to the end of total eclipse is 200 minutes. From these two facts, it was estimated that the radius of the moon is about a quarter of the radius of the Earth. If the size of the moon is known, the distance of the moon from the Earth can also be obtained. When you look up the full moon, close one eye and extend the arm forward. The size of your nails and the full moon appear to be about the same size. Then, due to the similarity of triangles, the ratio of arm length and half the size of nail is equal to the ratio of the distance to the moon and the radius of the moon. Since the ratio of the length of the arm and half the length of nail is about 100 to 1, it can be estimated the distance of the moon is about 20 times the radius. From here, find the distance to the sun and radius of the sun. First, find the distance to the sun. The value of θ obtained by Aristotle was 87 degrees. Therefore, the distance to the sun is about 20 times the distance to the moon. Substituting the calculated distance to the moon, the distance to the sun is about 955.5 times the radius of the Earth. Next, find the radius of the sun. From the figure, since it is triangle AOC and triangle BPC is triangle R similarity, the ratio of the moon radius and the sun radius is the ratio of the distance to the moon and the distance to the sun. Therefore, it can be seen that the Sun radius is about 20 times the Moon radius. Substituting the calculated Moon radius, the Sun radius is 4.78 the Earth 4.78 times the Earth's radius. The following figure is a summary of the above. From this result, Aristarchus thought that it was unnatural for the Sun, which is much larger than the Earth, to orbit the Earth, and that the Earth might be orbiting the Sun. By the way, it is said that Aristarchus did not know the Earth's radius. With this, only the ratio value can be obtained. After Aristarchus, there is a person who obtains the radius of the Earth by observation in the same ancient Greece. His name is Eratosthenes. He was director of the library of Alexandria and learned that in Siena the Sun would reach the bottom of the well on the day of summer solstice. He realized that this could calculate the size of Earth. In Alexandria, the angle alpha formed by the vertical rod and its shadow at the summer solstice was considered to be difference in latitude between Siena and Alexandria. He obtained alpha equals 7. He obtained alpha is 7.2 degrees. Since it was known from that time the distance between Alexandria and Siena was 5,000 stadia, which is about 782 kilometers. The radius of the Earth was estimated to be about 6,262.93 kilometers using this. Since the currently known radius of the Earth is 6,378.1 kilometers, so it can be said that the value obtained by Eratosthenes is quite accurate. If you substitute the value of the Earth's radius obtained by Eratosthenes into above table, it will look like this. Comparing this value with literature values, also the results are generally good for the Moon, but there is a considerable error for the Sun. So why did this result? The cause of large error about the Sun is considered to be the poor value of theta due to the low accuracy of the observation equipment at the time. In fact, if you substituting the correct value of theta is 89.85, the following table will be obtained. And you will get value close to literature values. From this, it can be seen that the problem was accuracy of observation. So the theory of Aristarchus itself was perfect. This picture was wrote by Aristarchus himself. The value obtained by Aristarchus was not correct, but his theory is perfect, and the value is enough to estimate the hugeness of the sun. And he obtained that conclusion more than 2,000 years ago. Either way, I think his achievement is so amazing. Finally, this is a reference to write this presentation. Thank you for listening.